would be parentheses, negative infinity to 1.
Excellent.
Parentheses, and then, yeah, that symbol that I don't know the name of.
Union.
Union. Yeah.
Put together. It can be replaced by the word or. So if you don't like the mathematical symbol, just write or. Same thing. Perfect.
Okay.
So then for this situation, allow me to move on to the next page. Very good question. Thank you. So for the domain, we have that. So now the graph, we have to write the ordered pairs. So of course, I will have to write 0. 0 has to be in the table at all times. And 1, and under 1, I don't have anything to put in. What does this mean? Undefined. I don't have a number to put in there. It doesn't exist. So I will plug in some numbers. First of all, I will plug in 0, so I get -1. I will plug in 2, and I get 1. We will also discuss the concept of the limit, hopefully today or Thursday. So you're going to see what happens here. These limits will be 0. Again, this is not for right now, but it was a question I want to show you. So, and now on the left-hand side, with values like 0.9, you will see that this will go to negative infinity. And with numbers like 1.1, you will see on this side will go to positive infinity. This is a more complicated, more sophisticated graph. The rational functions are not as friendly as others. Okay, so now when a rational function is undefined like it is in this case, x equals 1 will be a vertical asymptote. What does that mean? This. You will never cross it. And then from, I have 0, -1, which is right here. And then approaching 0 and going to negative infinity. From 0, crossing, going to negative infinity. So that's what I have to graph. And I have to write that x equals 1 is a vertical asymptote. Also, y equals 0 is a horizontal asymptote. And on the other side, as you see, it's coming from positive infinity. At 2 is 1, and it goes to 0. So this is the graph of y, or f of x, 1 over x minus 1. So this is how it looks like when it's not defined everywhere. We're going to see these graphs later on. Okay, I'm just going back to the graphs here. I'm sharing my screen. Is that what you had in mind, Jessica? I'm not sure, but I'm assuming, was it a yes?
She said yes.
Perfect, I got it. Good. So now we looked last time at the graphs. So we're continuing with R.3. We looked at graphs. We did not look at any of these problems. All super important. Please choose from here. I will choose first this time. If you, with your permission, I would like to choose 46. So this is g of x, the square root of 2 minus 3x. And then feel free to choose anything else you want from here, from 33 through 54. Okay, so I'm going to stop sharing for a second, and then we'll go back. Okay, what type of function is this? Say it again. Yes, yes. Radical. Yes. Radical function. So there are basically two types of radical functions. One, when the index is odd, right here, this number. What is the number here? It's not written, but we know it's 2. By convention, we don't write it. Or when the index is even. Now, when the index is even, does anyone remember how we determine the domain of this function. What has to happen here? What should this quantity be?
0 or positive.
Excellent. Only 0 or positive. Great job. Who was that? Was it Nick?
Yes.
Thank you. Okay, odd. Anything can happen. Negative, 0, positive. This one I call friendly. Of course, you don't have to write that. This one is not, because I have to worry about it. Every time I see an index that is even, I have to worry about it. Here, I don't have to worry about anything. Domain all real numbers. But here, most of the time, I'll have to find a domain. So then, what is the condition that I have to write for this function and solve it to find the domain? Anyone that I haven't heard from today, please.
Needs to be greater than or equal to 0.
Good. Excellent. But what?
2x, or 2 minus 3x.
Excellent. That's it. This is the condition that I have to write and solve. This quantity is called radicand. The radicand, the quantity under the square root, in this case, or the fourth root or the sixth root, the radicand has to be positive or 0. Now, if I have something like this, it can no longer be 0, though. For something like this, the condition is only greater than 0, because this quantity is in the denominator, but that's not the case here. So how do I solve this? Remember, I don't like minus minus. I move this term to this side, so negative 3x greater than. When I move a term from one side to the other, what happens?
Negative 2.
Yes, it changes its sign. And of course, I have to divide by negative 3. So then I have 2/3 and x. But something extremely important has to happen now.
You have to flip the sign.
I have to flip the sign. In case, thank you. Who was that?
Kirsten.
Kirsten, thank you. Okay, so the question is now, why do I have to flip the sign? So for some of you who don't remember that, is 3 less than or less than 10, let's say, or less than or equal to, it doesn't matter. Let's say I decide to multiply both sides by negative 1. Can I still keep this symbol? Is negative 3 smaller than negative 10?
No.
No. So that's the reason why every time we multiply or divide by a negative number, both sides of an inequality, we have to flip the symbol. So then the domain of this function would be, can anyone give us the domain? Anyone I haven't heard from? I heard from Kirsten, from Natalie, from Nick, from who else? Brianna, and I haven't heard from anyone
Would it
else.
be bracket 2/3 to infinity?
Careful. X, it's okay. Less than or equal to 2/3. Where do I start? It's okay.
Negative infinity?
Yes, negative infinity with a parenthesis. Yes. Comma.
0.
Careful. It says x less than or equal to 2/3.
2/3.
2/3 with what type of symbol?
Closed.
Exactly. Closed or bracket. That's exactly the same thing. We say it's closed or bracket. Excellent. That's all I wanted to hear. Any questions? Any questions? Okay, I'm sharing my screen and you tell me what else we want from here. If not, we move on.
Professor,
Yes, I'm here.
I have a question real quick. So when you put, I can't see it very well now, but you put 1 over the radical of x, and then you have comma x. Does that mean neither of those answers are correct?
I said that when the radical is in the denominator,
Uh-huh.
I cannot have 0 because 0 in the denominator will make the fraction undefined.
Okay.
So if it happens that a radical is in the denominator, under the fraction line, the domain will not have 0. It cannot have 0.
Okay.
We cannot divide by 0. Is that okay?
Yeah.
Perfect. Next question, we want to pick something or not? Or we move on?
54.
We want to look at 54. Perfect. So in 54, and this is 54 on page, what is it? 32, so you have it. So we have g of x, sorry. G of x equals 3x minus 10 divided by x squared minus 4x minus 5. Okay. So the same question, we want to find the domain. What is the first step? What is the thinking process? What do we need to do here?
Wouldn't you factor the
Excellent. Yes. Thank you. Who was that, Megan?
Yeah.
Good. How do we factor? Anyone can factor this for us?
-5 and 1.
X minus 5 and x plus 1. Who was that?
Natalie.
I couldn't hear you.
Natalie.
Oh, Natalie, thank you. Okay, perfect. So then we know from here, if you need to check, x times x is x squared, plus x minus 5x is negative 4x, negative 5 times 1 is negative 5. So then from here, the denominator cannot be, we just talked about it less than a minute ago, cannot equal to
0.
0. So then, what are the values that we will not be able to accept?
5 and -1.
Thank you very much. 5 and -1. So can anyone now state the domain for us?
It would be negative to infinity, -1, and then the union 5, and then to infinity. Or no, it would be -1, 5, then the union, and the 5 and to infinity.
Great job. Thank you. Good. Moving on. Do we need anything else? Any questions here?
I have a silly question.
No, no silly question.
How come in the previous question with 2/3 it was closed, and in this equation it is?
You see the equal symbol here?
Nope, I understand now. That's why it was a silly
The
question.
equal symbol, no. The equal symbol is a bracket, closed or bracket. And here we have to exclude. If I make a mistake and include, then -1 will be included.
I understand. Thank you.
Thank you. So x cannot be those values. Great job. Moving on. I'm sharing my screen. Moving on.
Could we do 52 really quick?
Yes, 52.
Yeah.
Yes, perfect. So 52. I see 52 is the absolute value of x plus 7. Good. So what type of function is this?
An absolute.
Very good. Good. What is the domain of this function?
All real numbers.
Very good. No restrictions whatsoever. If I give you any x, 1500 or -3 or any number, you will be able to determine a value for that function.
Is that the same with, I think it was 51, it was absolute with an x in it and then +1.
It's the question that doesn't, the question is not about numbers. The question is only about x.
Oh, okay.
Can x be anything? The answer is yes.
Thank
So
you.
are all absolute value functions kind of a trick question when it comes to domain? They're all going to be all real numbers.
Oh, this is a friendly function. However, if I have 1 over x plus 7 in absolute value, then x cannot be
-7.
negative 7. So it depends where the absolute value is located. So if it's in the denominator, then it's a combination of an absolute value and a rational function. And that's a different story. But if it's just plain absolute value, the absolute value is a friendly function. It's not a linear function, but it behaves like one when it comes to the domain only, not the graph. Good. Going back to sharing, we did talk, I do remember looking at this and answering all those questions. I don't think we have anything else from this. So I'd like to move on and finish up the next section.